So good morning to one and all. Today our topic is embedded firmware design approach. Still on, first unit is the introduction to the embedded system. The second unit is the embedded hardware design. So the third unit is the embedded software design or embedded firmware design. So basically from the definition of the embedded system, we already studied embedded system is a electrical mechanical system. It is designed for the specific application and it is the combination of both hardware and software. So that means it is the combination of the hardware components as well as the software. So from the second unit and first unit, we covered what are the basic hardware components, where it is used, what type of application, what type of hardware components it used. So the next level is the embedded firmware design. That is the embedded software design. So in this, the first topic is the embedded firmware design approaches. Today we are going to explain the concept of embedded firmware design approaches. So at the end of the session, we will be able to understand what are the different embedded firmware approaches and understand what are the steps involved in the design and development of firmware for embedded system. So the embedded firmware, it is the one of the important for any embedded product. So it can be acts as the master brain of the embedded product. So simply, without embedded product, the embedded without hardware and software. So after the designing of the hardware, without software, it should be like a born baby. That means, so the born baby cannot move. So where you can place, keep it there only. So without software, the embedded product should be like that one. That's why the embedded system should be like a born baby. So it can be acts as the master brain of the embedded system. So the firmware design approaches for an embedded product is purely dependent on the complexity of the functions to be performed. Speed of operations are required. So in the embedded firmware design approaches, we are using two basic approaches. One is the conventional procedural based firmware design. Second one is the embedded operating system based design. So two approaches. One is the conventional procedural based firmware design. This is also known as the super loop method. Another one is the embedded operating system based design. So first we will start with the super loop based approach. So that is nothing but the conventional based method. In the super loop firmware development approach is adopted for the application that are not time critical, where the time response is not so important. So that means it is similar to the conventional procedural program where code is executed task by task. So the task listed at the top of the program code is executed first. Then we will start with the next code. After completion of the next code, we will start with the third code. In this way, we are complete the entire tasks. So this is a true procedural one. In multitask based system, each task is executed in the serial approach. Suppose you can take the example. So the n number of tasks are there. Like, so the first task is completed. Then go with the second task, third task, fourth task. If the task is ended, then go with the first one. Again, first, second, third, fourth, five, like that. This is the way you can execute the each and every task in the super loop. This is the one of the example for the super loop based method. Suppose you are take the and traffic light control system. First, we will start with the green. After the green, we will start with the red. After that, green followed by the yellow. So this is the procedure we will start with. Same procedure loop will be repeated. So the same scenario will get in the super loop method also. This is the conventional based method. So one task is completed, then go with the second task. This is the way you can complete the task one by one. Task is completed. So suppose you need the firmware expression will be flow for this will be first. What are the thing? First, you have to configure the all the parameters, initialization of the various hardware components, memory, registers, etc. First, for anything, the first is the initialization of the parameters. Then we will start with the task one. So if the task one is executed, then go with this task two, task four. Like that, each and every task will be completed. So if the last task is completed, then go with the second task. This is the way. First, this task is completed, then go with the second task, third task, fourth task. All the tasks are completed, then go with the first task only. This is the way you can continue the approach in the embedded system. Embedded system super loop based approach. So this is also known as the conventional based approach. So this is the used for the applications where the time is not critical. Why? Because it will take more time. If the one task is completed, then another task. This is the way you can more time will be taken for this approach. So this is the one simple program for this C program. How the this is the void main configuration initialization while then we will start with the task and task three. The n number of tasks are completed in this way. So similar thing we are implemented in the super loop method. Super loop based method does not require an operating system. Since there is no need of the scheduling which task is executed and assigned by the priority, here there is no priority for the each and every task. Those tasks are implemented one by one from task one to task n completed. So in the super loop method, the priorities are fixed and the order in which task will be executed also fixed. So whatever the task is executed, all these are fixed. As per the procedure, one task is completed, then go with the second task. This is the way you can complete the super loop method. So super loop method does not require an operating system. Why? Because it does not any scheduling algorithms, any prior. It is used for the low cost embedded products like electronic toys. So they may not require for the operating system as well as there is no need of the time limit. So everything very simple applications we are using this super loop method. So the main thing is it is very cost effective. It is low cost applications we are using this. The main advantage is low cost application. Drawback is it will take more time. So it does not follow the timing. So example for the super loop method is electronic video gun by containing keypad and display. So depending upon the keys we are using in the electronic toy, as per the if it is up, down, right, left, these are four keypads. According to the four keypads only, it will start working. That is the one of the best example for the super loop method. So another thing is it is low cost. So there is no need of the requirement of the operating system. So coming to the advantage of the super loop, it is simple and straightforward. So I already told it is without any voice related overhead. So the drawback is it is lack of real timeness. Lack of real timeness. So another one is the if number of tasks is increased within the application, the time also increases. Another, if any part of the failure in the task, it may affect of the total system. Why? Because the n number of tasks are executed. If it is stop at the fourth star, again go with the first star. This is the way we are implementing in the super loop method. So it is really the one major drawback. So this is about the super loop method. What is the procedure for the super loop method? What are the advantages of the super loop method? What are the drawbacks in the super loop method? Next approach is the embedded operating system based approach. So in the operating system, we are having the two types of the operating system. One is the general purpose operating system. Another one is the real-time operating system. So general purpose operating system means it is similar to the conventional PC based application. So it is like Windows, Linux, etc. It is a desktop and we will create and run a user application on the top of it. So another one is the that is the general purpose operating system. Another one is the real-time operating system. So in the general purpose operating system, time is not critical. So timing not considered. Whereas in the real-time operating system, it will be a time-based. Everything will be respond according to the time. So the RTOs respond in timely and predictable manner to the events. So the real-time operating system contain real-time kernel for response, performing the preemptive multitasking scheduler for tasking multiple threads, everything. So the real-time operating system allows flexible scheduling of the system resources like CPU, memory, offers some way to communicate between the tasks. So the best example for the real-time operating system is the PSOS, VXWorks, ThreadX, MicroC OS 3, Embedded Linux, Symbian. These are the best examples for the embedded operating system. So thank you. Thank you, Ananda.